All right, here we go. Graphing 2x2 system. What you guys are going to be working on today is solving systems of equations using the graphing method. Now, this is a method that you guys should be familiar with. You guys have talked about it back in Algebra 1. It's just kind of a review of what you did back in that Algebra 1 class. All right, so the first thing you'll notice here is that we have two equations. And those two equations have the same variables, x and y. This is why we call it a 2x2 system. So what we're going to do is we're going to get our calculators out. And we're going to, well, before we graph it, what we're going to do is we're going to look at the table for the first equation, y equals negative 2x plus 3. So everybody go to your calculators, and let's go to y equals. And let's type in a negative 2x plus 3. Negative 2x plus 3. Once you have that typed in, rather than graphing it, I want you to look at your table, second graph. And we're going to complete this table that we have over here. I want you to look right next to your 0, 1, 2, 3, and 4. I want to know what are those y values. So let's start right next to the 0. What do you see right next to 0? 3. Right next to 1, you see a 1. Next to 2, you see a negative 1. Next to 3, you see a negative 3. And next to 4, you see a negative 5. So this is what you see on your calculator. So this is a table of values for that particular equation. What we're going to do is we're going to come over here and we're going to plot those points. So 0, 3 would be right here. 1, 1 would be right here. 2, negative 1 would be right there. 3, negative 3 is right here. And 4, negative 5 would be this point right here. Once you've plotted those points, what I want you to do is connect the dots for me. Now try and make your line as straight as possible, because the more accurate our line is, the better. There it is. So that is the graph of y equals negative 2x plus 3. Now what we're going to do is we're going to do the next equation. So we're going to go back to our calculators. Go ahead and get rid of negative 2x plus 3. And now what I want you to do is I want you to type in 1/2 x minus 2. 1/2 x. No idea. 1/2 x minus 2. Again, look at your table. And right next to 0, right next to 1, 2, 3, and 4, we're going to fill in those numbers. Let's start with 0. What do you see right next to 0? Negative 2. Next to 1, you should see a negative 1.5. Next to 2, you should see a negative 1. Next to 3, you're going to see a negative 0.5. And the last one, when you plug in 4, you should get a 0. All right, so these are the ordered pairs. We're going to plot them just like we did with the first equation. 0, negative 2 would be right here. That's 0, negative 2. 1, negative 1.5 would be right here. 2, negative 1 would be right here. 3, negative 0.5 would be right in there. And 4, 0 would be right here. So if I connect those dots, that is the line I get. So all I've done so far is graph both equations, also completed the two tables. Now you'll notice over here it says which ordered pair appears in both tables. If you look closely at those two tables, there's one particular ordered pair that shows up in both tables. Which one is it? 2, negative 1. Write that down for me. 2, negative 1. That's going to be important. 2, negative 1 is the only ordered pair that shows up in both tables. What do you call this point in terms of the system? We call that point 2, negative 1 the solution. That is our answer to the system. Solution, the answer. What do you call this point in terms of the graph? In terms of graph, we call that the point of intersection. It's called the point of intersection. And that point of intersection is going to be very important for us today, because if we can find that point of intersection, well, then we can also find the solution to our system. So basically what we're going to be looking at today is graphing two linear equations, finding that point of intersection, and whatever that point of intersection is represents our solution. All right, so let's keep going here. Important. When the equation in a system can be graphed. When the equation in a system can be graphed, then the solution to that system can be described using the coordinate of the point of intersection. When the equation in a system can be graphed, then the solution to that system can be described using the coordinate of the point of intersection. So our answers are going to be coordinates. They're going to be ordered pairs. That's what that's saying. We're going to have an ordered pair for our solution. All right, so let's see how this is going to work. I'm going to work a couple with you guys, and then I'm going to have some of you guys coming up here and helping me out. So make sure you're paying attention. All right, so here we go. First thing you'll notice is we have a 2 by 2 system. How do I know that that's a 2 by 2? How do we know? Just said it earlier. What does it have 2 of?
Variables.
It has 2 variables. What else? 2 equations. Right? 2 variables and 2 equations. That's why we call it a 2 by 2 system. We're going to start by graphing this one on the graph paper. So, first thing I need is the y-intercept. And the y-intercept is positive 2. So go ahead and put your dot at positive 2. That's your starting point. That's called the y-intercept. Next thing I'm going to use is the slope. Remember, slope is rise over run. So the slope on this one is 3 over 2, which means I need to rise 3, 1, 2, 3, and run 2, 1, 2. Up 3, over 2. Continue with that pattern. Go up 3, 1, 2, 3, over 2. The more points you have, the straighter your line is going to be. So get some more dots over here on this side. Let's go down 3 and 2 to the left. Down 3, 2 to the left. Down 3, 2 to the left. Again, the more dots you have, the straighter the line. Once you have those points connected, try and be as accurate as possible. There it is. There's the first equation. Now I can move on to the next equation. We're going to graph y equals 3x minus 1. That's what we're going to graph next. So, again, I need the y-intercept first. This time the y-intercept is at negative 1. Now the slope on this one is 3. But remember, we define slope as rise over run, which means it needs to be a fraction. Anybody know how to make 3 a fraction? 3 over 1. Put a 1 underneath. Which means we're going to rise 3 and run 1. Rise 3, run 1. So let's go ahead and go up 3. 1, 2, 3, over 1. 1, 2, 3, over 1. 1, 2, 3, over 1. Get some more dots on this side. Going down 3, 1 to the left. Down 3, 1 to the left. Once you have your points, you're going to connect those points. Again, trying to get as accurate as possible there. There it is. So notice I've got 2 lines. And if you look closely there, those 2 lines intersect each other. They cross. The question is where? Where do they cross? What is that point of intersection? What is that ordered pair up there, guys? 2, 2, 5. That point of intersection is important for us. What it is the solution. So down here at the bottom, that point of intersection represents our solution to this system. It's the only ordered pair that satisfies both of these equations. It's the only one. Okay? Let's try another one like that. Again, I'm going to do one more with you guys, and I'm going to start calling you up. So make sure you're ready. Got any questions? Make sure you ask. Yes, sir.
So the solution fits into that variable. So
in other words, the x value for both of these equations is a 2. The y value is a 5 for both equations. That's what we're saying with this ordered pair. The x is the 2, 5 is the y. All right, so let's go to this next one. And we're going to graph y equals negative 2/3 x plus 7. Plus 7, or the positive 7, is our y-intercept. It's our starting point. Now let's be careful on this one because that is a negative 2/3. So this time, instead of going up 2 and over 3, I'm going to go down 2 and over 3. Down 2, 3 to the right. I want to keep doing that. Down 2, 3 to the right. Down 2, 3 to the right. I can do the same thing going the other direction. Up 2, 3 to the left. Connect those points. And there's your line. That is the graph of y equals negative 2/3 x plus 7. Now I'm going to graph the other equation. We're going to graph y equals x minus 3. Start with the y-intercept. The y-intercept is a negative 3. That's where we're going to start it. Now I know it looks like there's no number in front of the x, but there is. Anybody know the number in front of the x? 1. But again, remember, we said slope is rise over run. I need that 1 to be a fraction. How do you make 1 a fraction? 1 over 1, just like we did earlier. 1 over 1. So that's what we're going to do here. We're going to rise 1, run. Rise 1, run. Up 1, over 1. Up 1, over 1. Up 1, over 1. More dots, the better. Okay, once you have all of those points, connect them. And now we have our 2 lines. Once again, just like the first one, these 2 lines intersect each other. Question is, what is that point of intersection? What is that ordered pair there? 6, 3. And that point of intersection represents our solution. The solution here is 6, 3. It's the only ordered pair that satisfies both of our equations. Nothing else will work. Alright, so again, all we're doing is graphing 2 lines and finding where they intersect. That's what it boils down to. Alright, so now I need some of you guys to show me your stuff here. So here's how it's going to work. I'm going to pick somebody at random here. And what you're going to do for me is you're going to graph just one of the equations. So right now I need somebody to graph the first equation, which is y equals 5 over 2x plus 7. That's all you're going to do for me. Alright, so the first person that's going to do that is Felix. Felix, you're going to graph y equals 5 over 2x plus 7. We'll go ahead and do the first one in green. Green. Make sure when you go up there, guys, don't put your hand on it. Just use the tip of the pen, otherwise it's going to pick that up. Alright, so there's your starting point, positive 7. Now what? Do you have enough room to go up 5 and over 2? No, that's right. So you're going to have to reverse it. Go down 5, 2 to the left. There you go. Keep going. Down 5, 2 to the left. You have enough room for one more? No? All right. Well, then connect those 3 dots for me. Make sure it's as straight as possible. Keep going all the way down for me. There you go. There it is. All right. So that is roughly what y equals 5 over 2x plus 7 looks like. Now let's get the next one here. All right. Adrian, you're going to graph for me y equals 3/4 x. What is that going to look like? 3/4 x.
What color do you want?
Blue. What's the y-intercept?
0.
There it is, 0. That's where you're going to start. Slope is 3/4. How many are you going to rise?
3.
And over, there you go. Up 3, over 4. Everybody else will be doing the same thing. Up 3, over 4. Looks like you're going to run out of room, so do the other side. Go down 3, 4 to the left. Down 3, 4 to the left. All right, connecting those dots. Remember, this line's got to be straight as possible.
Yeah, I can't.
I guess that'll work. All right. So there it is. So obviously we can see that these 2 lines are intersecting. The question is where? Samantha, I want you to come up here and tell me where these two lines intersect. You're going to highlight a point. So go up there and get the red pen. And I want you to darken in that point of intersection. Where are they crossing? Right? Very good. What is that ordered pair? -4 and there it is. -4, -3. So not only is it the point of intersection, but it also represents our solution. That's exactly what we're looking for. That's the only ordered pair that satisfies both equations. All right, let's try the next one, number 4 here. Again, I need somebody to come up here and graph the first equation. And Caleb, why don't you come up there and do that next one for me? -3/2x plus 1. What's that graph going to look like? -3/2x plus 1. Y-intercept is very good, +1. Now this is a negative slope. So we're going to go up or down? Down 3 and over 2. Make sure you go to the right. There you go. Keep doing it. Down 3 to the right. Very good. Let's get some other points on that second quadrant. Go up 3 and 2 to the left. There you go. Up 3 to the left. You got it. Go ahead. I think you can get one more. Right? Up 3 to the left. I think it's one more. And it's 1, 2, all the way up to the top. There you go. Now move over 2 though. There it is. All right. Connect all those dots. Trying to be as accurate as possible. Now the reason we're trying to be accurate, guys, because if our lines are a little crooked there, when we find that intersection point, it's going to be a little bit off. So that's why I want to try and be as accurate as possible. All right, let's get somebody else to come up here and do the next one. Matthew, why don't you come up here and graph the next one? 1/2 x plus 5. 1/2 x plus 5. Let's grab the blue pen for this one. Y-intercept is, there you go, 5. Slope is 1/2, up 1/2, 1/2. Good. Get some more points. Got it. Connect those dots. Very nice. All right. Olivia, why don't you go up there and find the point of intersection for me? Highlight it. And tell me what that point is. What is that ordered pair? Highlight it for me. Where do they intersect? There you go. Just darken it in for me. There you go. And what is that point? What is that ordered pair? -2, +4. Comma 4. All right, very good. Again, that is the solution to this system. It's the ordered pair that satisfies both equations. All right, we're going to move on to the next one. Now, this one's going to be a little bit tricky here. Let's see if somebody remembers how to do that one. All right, Regine, you're going to graph on me y equals 5. Let's see if you remember how to graph y equals 5. Now, remember, there is no x in this one. So the graph is a special graph. So what is that graph? Green. See if you remember. Y equals 5. Is there a y-intercept? What's the y-intercept? 5. So put a dot at 5. You know at least that one. So the y-intercept is 5. Slope. Is there a slope there? No. So what's the line going to look like if there is no slope? There you go. Draw that line for me. That is what we call a horizontal line. Everybody else should be drawing a horizontal line going right through the 5. That is the equation. Well, that's the graph of the equation, y equals 5. All right. Alexander, why don't you come up here and graph for me negative, what is that, 1/3 x plus 3. Negative 1/3 x plus 3. What's that graph? Let's look. positive 3 is the y-intercept. Now be careful because that is a negative slope. Now 1 over 3, very good. You got it, up 1 over 3. Alright, that is it. Now we're looking for the point of intersection, and that point of intersection is right there. The question is, what is that point? What is that ordered pair? What's that ordered pair, guys? Negative 5 or negative 6? Negative 6 and positive 5, right? Negative 6, positive 5. That is the only ordered pair that satisfies both of our equations. That is the solution to the system. You guys remember doing this back in Algebra 1? Is it coming back to you? A little bit? All right, let's do one more here. We got y equals 2x minus 1. And y equals 3 plus 2x. All right, Virginia, you're up again. 2x minus 1. Start with the y-intercept. Yeah, negative
1.
Yep, negative 1. But remember, it's the y-intercept, so it should be going on the y-axis.
Let me erase better.
Yeah, go ahead and erase. Okay, negative 1, that's your y-intercept. The slope is 2. How do you make 2 a fraction?
Put it over 1.
I'm going to put it over 1, so it's 2 over 1. So we're going to rise 2, run 1. Go, keep doing that. Up 2 over 1. You got it. Get some more dots on the other side. Down 2, 1 left. And connect all of those dots. Let's try and get it as accurate as possible. Perfect. Perfect. Okay, Olivia, come on up here and do 3 plus 2. This is a little bit trickier here. You got to really be paying attention to this next. Let's see if she catches it. Y equals 3 plus 2x.
Wait, red? No, blue.
That's good. What's the y-intercept? Look at that thing closer. What's the y-intercept?
3.
There you go. Very good. 3. Positive 3. And the slope is 2 over
1.
1. So we're going to go up 2 over 1.
Oh.
You got it. Get some more dots. There you go. Down 2 over 1. Down 2 over 1. Okay, connect all those dots. Here's something a little tricky. All right, thank you. What we're looking for is the point of intersection. We want to know, where do those 2 lines meet? Where do they cross at? Well, what do you notice about these 2 lines? They're parallel. So are they going to cross each other? No. So if they don't cross each other, what kind of answer are we going to have? You're not going to have an answer. Because remember, what are we looking for? We're looking for where they cross. And if they don't cross, well, then there is no solution. No solution. So anytime you have 2 lines that are parallel, there's no solution. No solution. All right. I've got one little quick thing we're going to look at here. This graphing method. Now, sometimes we don't always have graph paper handy, but we do have our calculator handy. And the calculator can actually find an intersection point for you. As a matter of fact, we've done this before. So we're going to look at just 2 examples on how we can use the calculator to find that intersection. All right, so if you look at number 7 here. Number 7, we're given the system 2x plus y equals 5 and 4x plus y equals 12. Now, if I'm going to use the calculator, they must be in slope-intercept form. And right now, that's not the case. So I want to start with this one right here. I want to convert that into slope-intercept form, which means the 2x needs to be over here on the right-hand side. How do you move the 2x to the right-hand side? Subtract it. So now what we're going to have is negative 2x plus 5. All I did was subtract the 2x. Now it's a slope-intercept form. We're going to do exactly the same thing with the second equation. 4x plus y equals 12. I want it in slope-intercept form. So I'm going to move the 4x over to the other side, and we do that with subtraction. So now I've got negative 4x plus 12. Now both of these are in slope-intercept form. All right, so here's what you're going to do for me. You're going to go to your calculator, and you're going to go to y equals. And what we're going to do is in y1, we're going to type in a negative 2x plus 5. In y2, we're going to type in a negative 4x plus 12. So you're going to graph two equations at the same time. So make sure you get both of them in. Go ahead and graph it. And whatever graph you see on your calculator, I want you to put that for me right here. Sketch me a graph of what you see on your calculator. Doesn't have to be anything perfect right now. We're just getting a rough sketch of what you see on your calculator. All right, this is roughly what you guys see on your calculator. Not exact, but roughly. What we need to do is we need to find the point of intersection. We want to know where are those two lines crossing. Well, we can actually tell the calculator to find that for us. We've done that before. We go to second trace. Second trace. Number 5 is the one we're going to use, intersection. Number 5. However, remember, you're going to have to hit enter how many times? 3 times before you actually find that point of intersection. So hit it 3 times. And what values do you see down here at the bottom? 3.5, and the y value is negative 2, which means that these two lines intersect at 3.5 and negative 2, which also means our solution is the order pair 3.5 and negative 2. That is our solution. Wherever they cross is the solution to the system. Now notice over here it says table check. I want you to go to your table for me real quick. Everybody go to your table. And I want you to find 3.5. And everybody find 3.5 in your table. Not everybody. And that's because some of you don't have it set up to show decimals. All right, so here's what we're going to do so that everybody can see that 3.5. We're going to adjust our table. The way we do that is by going to seconds. Second window. Second window. And the second option, the one that has like a little triangle that says table, for most of you guys it probably says 1 right now. If it says 1, I want you to change it to a 0.5. Change it to a 0.5. Now look what happens when you go back to your table. Go to your table, and notice now what it's doing is it's counting by 0.5s. It goes from 0 to 0.5 to 1 to 1.5, 2, 2.5, 3, 3.5. I want you to find 3.5. And I want you to notice what's sitting right next to that 3.5. What do you see right next to that 3.5? Negative 2 and a negative 2. Why are there 2 y values? Well, because we typed in 2 equations. That's why you're seeing 2 y values. Wherever the 2 y values are exactly the same number, that's where we can find our point of intersection. Just like we did the other day with our solving equations. Pretty much the same thing. Okay, so if you can't find it on the graph, we can always come and look for our table and find where the 2 y values are exactly the same number. All right, let's try one more here, number 8. Number 8. I want to take this first equation right here, 4x plus 7y equals 14, and I want to rewrite it in slope-intercept form. So what I'm going to do is I'm going to start by moving my 4x over to the other side. Then I'm going to divide everything by 7. So a negative 4 divided by 7 cannot be reduced, so I'll just leave it as negative 4 over 7. 14 divided by 7 would give me a 2. So the slope-intercept form would be negative 4 over 7x plus 2. That's what we'll be putting in the calculator here in a second. But before we do that, let's go ahead and take care of this one also. Let's take care of the 8y plus 8 equals 5x. All right, so here's what I'm going to do. I'm going to start by moving the 8, this 8 right here, to the other side. And the way we do that is by subtracting. So now what I have is 8y is equal to 5x minus 8. Remember though, I want y by itself, so we're going to divide everything by 8. 5 divided by 8 cannot be reduced, so I'll just leave it as 5 over 8. A negative 8 divided by a positive 8 would make that a negative 1. So what I have is the equation 5 over 8 x minus 1. Alright, now that you have the equations, go ahead and put that in the calculator for me and find me the solution. Find me the point of intersection. Done the hard part. Put it in your calculator. Graph it. Find the point of intersection. Now we'll give you a little heads up there. This solution that you get will probably be an ugly looking decimal. And if that's the case, round it to 1 decimal place. 1 decimal place. On 1 decimal place. All right, Livia, what did you get for your solution there? What was the decimal? 2.5 and 0.56, but if I go 1 decimal place, that would make it just 1 decimal place. Just 1 decimal place would make it 0.6. All right, so our solution is 2.5, 0.6. That is the ordered pair that satisfies both of these equations. All right, so that takes us through solving systems of equations using the graphing method.